those things. The instruction related to that comes under arithmetic operations. Then we have logical operation and or basically the digital logic operations. So the instruction which are used to perform the logic operations are there in the logic operation group. Then we have some branch operation, machine control operation. I'll discuss that. So yeah, there are various. I guess yeah, addressing modes is next. We will discuss. So we have different type of instructions. So what addressing mode is, how we are specifying the data in the instruction, basically specify the addressing modes. We have 5 type of addressing modes. One is register addressing mode. Suppose we are writing an instruction and specifying the, like whenever we are writing an instruction, we are going to perform some operation on some data, right? So in case we are providing the data via a register by mentioning a register, then that is called register addressing mode. Suppose example, I've written an instruction over here, move A comma B. What it means in case of 8085 is, so this instruction basically moves the data which is stored in register B into A. So we are not directly mentioning the data in the instruction, but we are mentioning the register in which the data is stored. Then we have immediate addressing mode. In this, we are in the last case, we were specifying the register in which the data was stored. In this case, we are directly mentioning the data on which we need to perform some operations. Suppose, like for an example, I've written MVI A, 05H. So this, what this instruction do is, we call this instruction and move immediately. So this data, so what this instruction does is it moves the data 05 into accumulator. So 05H, the data we are directly mentioning in the instruction. So we call it immediate addressing, directly mentioning the data into an instruction. Then we call it immediate addressing mode. The third one is the direct addressing mode. In this, in the first one, we were specifying the register. In the second instruction, we were specifying the data. In the third, the direct addressing mode, what we do is we basically specify the memory location in which the data is stored. For an example, the instruction called STA 7500H. So this, what this instruction does is, we are mentioning the memory location over here. So what this instruction does is this instruction moves the data stored in memory location 7500 into the accumulator. So rather than mentioning the register, rather than mentioning the data, what we are doing is we are mentioning the memory location in which the data is stored. And I've just written few examples of the instructions over here. Right. The fourth one is indirect addressing mode. So in the first one, we were mentioning the register, then we mentioned the data. Lastly, in the last instruction that we addressing mode that we discussed, we mentioned the memory location. In this addressing mode, the indirect addressing mode, what we do is we store the memory location in some register, and we use we point to that register, and like I'll just give you an example via the instruction. So what we have done is LXI H, what this does is this moves 7500 into the HL pair, basically register H and L, and move A comma M. In this, what this does is this basically, whenever you are writing M in any instruction, it basically points to HL pair, the data stored in HL pair. Suppose I have written move A comma M. So what this instruction does is it will look into H and L. It will use the memory location stored in H and L, and it will take data from that memory location. Like we are storing the memory location in a register, and we are taking the data from that memory location. We are not directly giving the data. We are not directly taking the data from the register. We are not taking the data directly from the memory location. We are storing the memory location in some register, and then we are taking the data from that memory location. This is called indirect addressing mode, mentioning the register in which the memory is stored from which we need to take the data. The last one is the implicit or implied addressing mode. So in which in this specific separate data is not mentioned, the instruction itself specifies the data on which we need to work on. Suppose instruction is RAL. So what this instruction does is it rotates the data content of the accumulator towards left. Like accumulator is having 8 bit of data, so it will be shifting the data 1 bit towards the left. So we are not specifying the data or anything over here. The operand on which we need to perform the operation is there in the basically instruction over here. All right. So there are some various type of instructions. I'll just discuss these while writing some programs over there. Okay. So I'll just now move to the basically simulator directly. I guess theory will be a bit boring to discuss, right? So these type of subjects we used to do in 6 months. So discussing all the theory, I guess in 1 hour or half an hour isn't that practical or interesting as well. So I'll just move to the simulator. So the simulator that we'll be using today is, just a second, yeah. Okay, so the name of the simulator is Sim 8085. Okay, so what you need to do is you just need to write Sim 8085 on Google. Okay, so the first page which is coming, sim8085.com, you just need to click on that. Okay, so it is an online simulator. You need not to download it or install it. It is an online simulator. All the processing will be done in the online mode only. Okay, so when you are opening the window, it looks something like this. Now I'll just brief you about what the various windows mean. Sim 8085. Yeah, I hope you all would have opened it. Okay, so we'll be parallelly doing some programs, right? So what I want you to do is, and the online participants to do is, just as I'm writing the program, you can parallel. I'll be just giving you a minute or two to write the same program so that you can have an idea about how it works. Okay. So this is the programming window. So all the programs that we need to write will be written here only. Okay. Then this is the machine code window. So there are two, we know that we work on the assembly language, but there is an equivalent machine code to every instruction that we are writing. So the machine code, this simulator will be, once we assemble it, it will be providing us the machine code here. Okay. This, if you're clicking over here, I'm just expanding the lab. So this shows various registers. What all registers were there? We have the accumulator, program status word. Then we have B register, C register. So they have given it in a pair. We can modify it as well. I'll just let you know. Then we have D and E, H, L, stack pointer, and program counter. Then we have some flags, sign, 0, auxiliary carry, parity, and carry. Okay. Suppose we need to preset some value into these register. What we need to do is just double click on it. Suppose I want to modify the data in B. You can just modify it, write whatever you want, and just press enter. So the data will be modified. So similarly, for any stack pointer, HL, DE, you can modify the data if you want some preset values while you are executing a program. Then we have some, we have 5 flags. So flags can be either set or reset. So in case if you want to set a flag, preset a flag, you just need to click on it. So the flag will be set. If you want to reset, so you can just reset it. Okay. So this is about the registers. Then we have memory locations, right? We also need to take data from memory location in order to execute some instruction. So if you click over here, so memory location will open. So what you need to do is, there is a wide range of memory location in 8085. Suppose you want to see a specific memory location. So you just, once you click on it, I'm just closing it again. Just click on this plus arrow, write whatever memory location you want to access. I suppose want to access 2001 to I guess, or 3001. Yeah, 3001. Okay. So just click on watch range, and all the memory locations will be opened over here. Right. So same is the case as was with the registers. In order to modify the memory. Yeah,
sir,
yes, please.
Sir, can you zoom in a little bit so that we can clearly see what you are typing?
Sure.
Thank you so much, sir.
Yeah. Okay, I'll just tell this again. You can delete it. Like, Suppose you want to look into a specific memory location, just click on this plus, whatever memory location you want to access, right from to, suppose I want to access memory location 2001 to 3000, right? Then I'll just write it over here and just click on watch range. Okay. So this way you can have all the memory locations. Suppose I want to modify it, just double click on it, 05, and it will get modified.
Sir, what is this 0x in the starting of
Yeah.
the address
So
0x?
this is basically a suffix. You just need to focus on this the address only. Okay. So parallelly, if you want to access some other memory location, I want to access from 10. So you can just click on plus and go into watch that range as well. Okay. Yeah. It is basically used to 0x is basically used to specify hexadecimal data.
This address line is 16 bits, so
Yeah.
4 bits are taken from that.
So if I want to switch from one memory location to other, just double click on it. I guess there are some network issues. Okay, yeah. So you can just switch from one memory location to the other just by clicking on it. So you can have various chunks of memory location that you want to access. Okay. Yeah, just a second. Then we have some input output ports. You can access those as well. So now let us start practicing some of the programs. Yeah, this window I have missed. So suppose you have written a program over here. To execute the program, you can just click on load and run. Okay. Then suppose what this will do is this will just load the program and execute it at once. Okay. From which part you want me to repeat? Previously, I was talking about memory location. So there I've already told you, like you can just write the range of.
How to run?
I'm not getting. Okay, how to run? I'm just getting to it. Okay, yeah. So what I was saying is this is the location where I'll be a little bit slow. Okay, so I wanted to focus more on 8051, but that's okay. So this is the window in which we'll be writing the assembly programs. Okay, in order to execute it, there is a green button over there. If you'll just hold on it, it will say load and run. So what this will do is whatever the code you have written, it will execute the code at once. Okay. So second option what we have is, suppose we are having some complicated set of program, a very long written program over there, and we need to execute the program line by line. Then we have this debug, load and debug option over there. If you click on this, then the instructions will be executed line by line. You will be getting the result of what every line is doing, what is the output of every line. So this way you can debug your program as well. Okay. Yeah.
Is the step run?
Step run basically. Yeah, right. Okay. So let's start by writing some basic programs. Okay. Yeah. So I'm just clearing the window. The basic program which we teach to our students is, I guess we start from the addition program. So we'll write that only. Okay. So suppose you want to write an instruction, you can simply write it. Whenever you are writing an instruction, it will get highlighted. If it is recognizable by the color has changed, you can check. So the color will change in case it is a write instruction. So suppose I'm writing MVI A, 02H. Okay. So I'm just executing some basic instructions initially. So what this instruction does is it basically moves the data 02 into accumulator. Okay, I'm just moving to the accumulator. Okay. Suppose you write, you guys can parallelly write it as well. Suppose you want to write some comment. What you have written, whatever you're doing in that particular line. So you can just use a semicolon and write whatever you want to write. Suppose I'm going to move data 02H into accumulator. Okay. So whatever comments you want to write, you can use semicolon and you can write whatever comment. Same is the case with, I guess you already had a session on Arduino. So Arduino, we use slash over there to write the comment. So here you need to use a semicolon. Okay. So what this instruction does is it move the data 02 into accumulator. Let us just execute it to check whether the simulator is working or not. Okay. You just, in order to execute it, just click on load and run. Yeah, so once you run it, it will say that in case of error, it will highlight the error. In case the program ran successfully, it will highlight that yes, it got executed. So you can see the data in accumulator initially was 00, but once we executed this program, the data got changed to 02H. Right. So this is what we were calling immediate addressing. I'll just let you know various type of addressing modes. Immediate, right? So what we are doing over here is we are mentioning the data directly in the instruction that we want to execute. Okay, let us write another line. Let us do register addressing now. Move B, comma A, right? So what this instruction does is move data from A into B. So what we used to call it, this is called register addressing. I hope the online participants are also writing the programs parallelly. Okay, so this will be having an idea of how to use the simulator. Okay, what I'll do is, in order to reset all the registers, you just need to click over here. It will reset the registers to the initial value. Right. So if I read the program at once, what it is doing is it is initially moving the data 02 into accumulator, and then it is moving the data from accumulator into B. Okay. So if now I execute it, I'll just click on load and run.
Sir, in the A byte is given 0202.
Yeah, so this is program status word. We are not, it automatically gets increment. We are only, this is the part dealing with the accumulator, the first two. Yeah. So after I executed this instruction, you can see the data 02 is now in accumulator and in register B as well. All right. Parallelly, we are getting the machine code as well, right? So we have done the register addressing as well. Okay. Suppose you want to clean the data, reset the register, just click on this. It will get resetted. Okay. Now what we'll do is we'll do direct addressing. In direct addressing, what we are supposed to do, we are supposed to take the data from a memory location. Okay. So I'm just changing the line. So one of the instruction set, I guess you guys can refer the books and textbooks for that. Whatever instruction I'll be writing, I'll explain that. But there are a chunks of instructions you guys can basically go through that. While if you with respect to whatever program you want to write. There is an instruction called LDA. I am writing 200. What this instruction does is it does move data from location 2001 H into A. This we call as direct addressing. We have done three type of the registers value or the program. Just select it and delete. Simple. Or the program window is what you're saying, I guess. Or the registers. Okay, the registers you want to reset.
The data is read only.
No, you can just click over here and delete it. Just
in the machine code, it will read only.
Not in the machine code. You need to just select all and just press escape.
Its editor is read only.
Restart the page.
Yeah, let's do an IT thing. IT guy suggested just reload the page. I hope. Okay, yeah. So what this instruction does is, so initially we did immediate addressing, then we did register addressing. Now what we'll do is we'll move data from 2001H into accumulator. Okay, I'll just change few of the lines. Here, I'm now moving data 05 into C. Okay, so this instruction now will move the data in 2001 into accumulator. So for that, we first need to access the memory location. Yeah. So this is the memory location 2001. So suppose I write 088 over here. Yeah, I modified it to 08. Okay. So now let's do step-by-step execution of the instruction that will give us a good idea of how the instructions are working. So to do the step-by-step instruction, you need to click on this load and debug.
Editor is read only.
Yeah, so for that, you need to first stop the debugging. I thought you were doing the execution of the program at once. So suppose now we are in load and debug mode. Now what this will do is this will do the step-by-step execution. Okay. So we are where we are right now, where the CPU is right now, it will highlight that instruction. So as of now, the CPU is on the first line. So once we execute it, what it should do, it should move the data from 2001, which is 08, into the accumulator, right? Yeah. So to execute one instruction, again, you need to click over here. Okay, now we can see the cursor move to the second location and 08 got moved into the accumulator. Right. In order to execute the next instruction, again, click on this. So this instruction was supposed to move 05 into register C. So now register C got modified. Then moving the data from A to B. Yeah, so data in A was 08. Now the data is changed to 0. In B is also changed to 08. All this to stop the instruction. So once you are into debug mode, in order to edit the program again, just click on this red icon, which says stop debugging. Right. Okay. So let us do an basic arithmetic operation. What we'll do is we'll take the data from two memory locations and we'll just add it and store in some register. Okay. So I'm just deleting it. In order to clean it, you can either select it and press backspace, or you can just click on this. Everything, every memory location, everything will be clean. Okay. Oh, I guess you need to scroll. Okay. Yeah. I'm just removing these instructions. So what we'll do is to perform an arithmetic operation, we need to have two numbers. So first number we'll take from 2001H. Okay. Right. So what we'll do is we'll move this data into some other register. Move data from A to okay. Now we need to have second number. So we'll take the second numbers from some other memory location. Let us take it from the next memory location only. I'm writing it load data from 2002H into. Okay, now we are having two numbers. Parallelly, you can also write, the online participants can also write this program in the window. Okay, I'll be just moving a bit slow. Okay, So what we have done, we have taken the first number from memory location 2001. The first number which we took into A, the data will be loaded into A. We are moving that to register B. Then we are taking the second number from 2002H. Okay. Now we are having the two numbers. What we need to do, we need to add the two numbers. So there is an instruction called add B. What this does is add data of B into A and store result in A. Okay. Yeah, great. So what we did is we loaded the first number, we moved it into B, we loaded the second number, we added both the numbers stored into accumulator. Okay. Suppose you want to store, suppose you want to store the number into some memory location only. Then we have instruction called STA, right? STA 2003. Let's write. Okay.
लाइट चल रहा है हेलो 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 लाइट चल रहा है दिखाना एक बार
Like this चल ही रहा है.
ठीक है
Yeah. So I'll write meaning of this as well. Store result in 2003. Okay. For that, let us just modify the memory locations. In 2001, I'll write number 02. Some simple numbers. In 2002, where we were supposed to have the second number, I'm writing 04 or 07 or 4, anything like that. Yeah. So now we have modified the memory locations. Now we'll do the step-by-step instructions. Step by step. Yeah. So once we execute it, the result 6 should be getting stored over here. So rather than us loading and running it at once, I'm again doing step-by-step execution. Load and debug. Yeah. So ultimately, 06 should get stored over here. Yeah. So initially, the data from 2001 should get moved into accumulator. Yeah. So now we are having 02 in the accumulator.
In step run, we need not give any instructions, it goes on its own.
Yeah. In the step run, yeah, we need to click one by one. Yeah. I'm clicking every time. Yeah. So this depends upon the internet connection as well. So if you click on this, then all the instruction will be get executed at once. Okay. So now move B, A. So data from A will get moved into B. Now after it gets executed, 02 is getting moved into B. Okay. Now the data from second location, that is 04, will get moved into A. Executing it. 04 is now in A. Add B, so add both the numbers and store in accumulator. (02) plus 04 is 06. So now the result is in accumulator. Now store the result in 2003H. I'm executing it at once. Yeah. So now let us check the memory location. You can see the result is stored in the next memory location. I guess, yeah. I guess everyone would have executed it. It is a very simple program. Right. So another thing is, yeah, so there can be a carry as well in some of the arithmetic operations. So let us do that as well. So through that, we'll be getting to know about some jump instructions. Okay. So we need to have a register in which we'll be storing a carry. So let us initialize C. We'll be storing the carry in register C. Carry to be stored in register C. So why I have moved 00 in C? Yeah, we are clearing it because here we are knowing it, but when we are specifically working on the microcontroller, we might not be knowing what the data is there in C. Okay. Okay. So here I'll be storing carry. So after adding both the numbers, we need to check whether there is a carry or not. In case there is a carry, what we'll do is we'll increment register C. Increment if carry is there. Okay. Right. But in what case it need to increment? What I'll do is jump on no carry to some location. You can specify the memory location, or you can write some like operand, a letter over there which you can refer in the program. Next, suppose jump on no carry to some memory location called next, or whatever. Okay. So if there is no carry, what this instruction does is it asks the program to just move to the location where this thing is written. Suppose I'm writing next over here. Okay, so what it will do is, if there is no carry, jump on no carry. It will jump to this location. It will just skip this line and just move to this location. Okay. And if there is carry, then it will not jump. It will execute the next instruction, then it will move over to this location. So let us store the carry also in some other location. So what I'll do is, after storing the result, I'm moving the carry in A. Move carry to A. And let us store the carry in some other location, 2004H. Store carry to 2004H. Great. Okay. So I'm just resetting the registers by clicking on this. Resetted. I'm just writing some numbers. Suppose we have FF in 2001. I'm trying to use some numbers which can generate carry. Okay, now let us execute it. Load and debug. So yeah, so first instruction will move 00 to C. There already 00 is there in the C. The next instruction will load the data from 2001 into A, which was double F. FFH. The next instruction will move FF into B. Next instruction will move the second location, second data into accumulator 04. Next, we are adding both the numbers. We are getting 03, and there will be a carry. You can see the carry register is set after this result, right? So it says jump on no carry to next, but if in this case there is a carry, so it will not jump. It will move to the next location. It will increment C. So 001 will get changed to 01. Now I'm just executing it. Now if we check, 03 is there. The sum is there in 2003 location, and the carry is in 2004. Yeah, so this is a basic addition program. Okay. So similar way, what I'll do is, in one of your assignment, I'll just give a program for subtraction. I guess that can be done in the similar way. So what you will do is, you'll just take the number from two locations. In that case, the instruction will be sub B, and then also you can check for the borrow using carry register only, and just store the subtraction result and the borrow in some location. So this will be a part of your assignment, just to make you get used to this. I hope everyone has executed it. If there is any doubt, you guys may ask. Yeah. Okay. Right, I'm moving to the next. Let us do multiplication program, another basic program. But so,
Hello.
yes, please.
Yes, sir. Actually, in my screen, from a editor is loading coming from a very long time. Is there any login requirement or can be?
Okay, it is
The
loading
main-
very slow. Are you saying that?
Yes, sir, it's true.
Actually, it basically depends upon the internet connection. Not a big fault of the simulator. I've used it for a long time, so I guess there might be some internet connectivity issues. Otherwise, it moves it executes very smoothly.
Okay, okay, sir. Thank you.
So I hope everyone has written it. Okay. So let us do, I'll just do one or two programs, then we'll move to 8051. That will be a bit more interesting for you. We'll be interfacing some peripherals in that. Okay. Yeah. So now let us do multiplication program. So what I'm doing is I'm doing a multiplication program. So there is no direct instruction. If you guys know, there is no direct instruction to multiply two numbers in 8085. Yeah. Successive addition is what we'll do. In MUL is there in 8051, not in 8085. So in 8085, you don't have an instruction to directly multiply two numbers. So what we'll be doing is we'll be doing multiple addition, successive additions basically. Yeah. So we'll develop some counter and do successive addition. Okay. So what I'm doing is initially as in the last case there can be a carry, so I'm initializing D for carry. Okay. Yeah. There can be two methods of doing it. Okay. Now let us do indirect addressing in this case. So in indirect addressing, we will store the memory location in some register pair and we'll point to that memory location. We have already done register direct and indirect. In register direct and immediate, we'll do in indirect addressing. So there is an instruction called LXI. Yeah, right. We'll use okay. Load HL with, I'm just writing with respect to memory location. Yeah. So what this instruction does is, so it moves 2001 into H and L pair. Okay. So as we need to have a memory location in some register, so memory location is of 4 digits, right? So we need to use a pair. So we are using HL pair. 1 second. Okay. Now the instructions here. Yeah. So there is an instruction called move B or A or anything, comma M. So what this does is move data from M pointed by HL pair. Let us just execute it. B comma 20.
Need to be clear HL pair.
Yeah. We need, in this specific case, no, we are already moving some data into it. So there is no issue of that. The clearing is required where you are supposed to do some increment, right? Where you don't know what the data is there. Suppose we need not to clear A or B because we are directly moving some data into it. It anyways will get modified. So let us execute it. This just to have an idea about this addressing. Yeah. I'm writing 02 in this. Yeah. So debugging it. Okay. So first instruction is just to move 0, 0 into D. This is not multiplication program. I'm just giving you an idea about how indirect addressing is working. So this instruction will move 2001H into into HL pair. Yeah. So now you can see the data 2001 got moved into HL pair. Now what next instruction will do is it will move the data pointed by M. M always points to HL. So it will basically move the data pointed by memory location stored in 2001. The data pointed by this register pair, which is 2001. It will take this memory location. It will take data from that memory location and store in B. We call it indirect addressing. I'm executing it. So data was 02. Now you'll see 02 got moved into B. This immediate addressing, indirect addressing. Okay. So we are not directly not specifying the memory location as well. Okay. Yeah. Okay. So I'm just stopping it. Let us. Okay. Yeah. So the first data to multiply will store in 2001. The second data will store in 2002. Yeah. So in order to point to the next memory location, either what we can do is we can write LXIH, 2002H, and then do some move, something C, M. But like while developing a product, what we do is even the execution time of a microprocessor or a microcontroller is very, very important. Right. Yeah. Exactly. So we need to use some instructions. If we have an option, we'll be using some instructions which are easy to load, which take less time. So I'm writing INX H. So what this instruction does is increment the data in HL pair. If it would have been some other memory location, suppose it would have been 2005, then this wouldn't have worked. As I'm just using the next memory location, I'm just incrementing it. Move from 2002H to C. Now what we'll do is B, we'll store, just a minute, add data from B to A. Okay. Okay.
C
should be moved to A.
Yeah, I got a point. There are various ways of writing a program. I'm just explaining it. Okay. So we have the first number in B. We have the second number in C. So what I'll be doing is I'll be adding B into A. How many number of times? That is the number which is stored in C. That. Yeah, I'm just initial. Great. Right. What we could have done is if we would have stored the data directly into A, then we could have done one decrement of C before. Yeah. So this instruction, what this will do is this will add the data from B into A. Okay. So once we have added the data one time into A, we'll just decrement C. Okay. Now we'll check, like what we are doing is we are doing the successive addition. So we'll check
Jump on
jump on no
0.
zero. We'll check whether C is 0 or not. I hope everyone is understanding. What we are doing is suppose we are doing the multiple addition of B into A. The number of times, how many number of times? The number stored in C. So every time we are doing the addition, we are just subtracting, we are decrementing the C and checking whether C is 0 or not. Jump on no 0 to some loop. I'm calling it loop. Yeah. So what it will do, it will add B into A, check decrement C and check if C is 0 or not. Yeah. And lastly, what we'll do is store it in some memory location. Yeah, I'm getting to that. Let us just build step by step. Store multiplication. I've left the space for that only in 2003. But as I initially said, there might be a case that there is a carry. So we'll be checking for carry as well. What we'll do is same as we did in case of addition program, jump on no carry to some memory location called next. If there is no carry, just jump to this memory location. But if there is a carry, increment the carry register. Okay. So what we are doing, I'm just explaining it again, adding B successively into accumulator, decrementing C. How many times we'll add? Till the time C is not 0, we'll keep adding it. Parallelly, what we are doing is we are checking carry. In case there is no carry, we'll skip incrementing D and just keep decrementing D. In case there is a carry, we'll increment D. Then we'll move to the next instruction. Then finally, we are storing the result STA2003H. We have already used this instruction. We are moving. Now we'll move the carry into accumulator. Move carry to accumulator. Now we'll store the result, basically the carry in some location. Store carry into. So there can be multiple ways of writing the same program. I guess you guys can obviously write it more efficiently as well. I've just written it a way in which it is easy to explain. Okay, so let us do step-by-step execution of this program. So I'm debugging it. So initially it will basically initialize A and D to 0, 0. So now both A and D are 0. They were 0 earlier. So now we'll move 2001 to H. 2001 will get moved to H. Now the memory location which is there in 2001, the data from that will get stored into B. So data is 02. This will get stored into B. Right. Next, we want to point to the next memory location. We'll increment HL 2002. Now move the data from the next location, that is 2002, into C. 2002 is having 04, so it will get stored into C. Right. So we are having our two numbers 02 and 04. Okay. So we are starting the loop. We'll add B into A. So B is having 02, got added into A. If there is a carry, if there is no carry, just skip it and move to this. So there is no carry, it will just skip it and move to this location. Now we'll decrement C. C will get changed to 0, 3. In case there is no 0, just repeat it. So C is not 0. Again, coming to the same part. Now again, we'll add B into A. So the data will get changed to 0, 4. Same thing gets executed again and again. Yeah, I'm just executing it quickly. Okay. Yeah. So this now again it will add 02 into A. This will now get changed to 08. Jump on no carry to next. There is no carry. It will just move to this location. Decrement C. Now C earlier was 01. It will now get decremented to 00. Now it says jump on no 02 loop, but there is 0. The C got changed to 0. 0 flag is set. It will not jump again. It will just execute the next instruction. And again, now we are just storing the results. Okay. So 04, if you are multiplying 04 with 02, 08 is the result which got stored in 2003H. Yeah, so the same way you can execute different sort of programs. I guess I'll just wrap up this 8085 thing. I hope everyone would have executed it. So very simple to use, though I guess it is getting removed from some of the curriculums, I guess so. Yeah, but still it, from our earlier memories, it used to be a very good learning point for us for getting into the microcontrollers. Yeah, right. So dear to all of our hearts. I guess. Right. So this way you can execute different instruction programs. I'll just give you some practice programs to execute it. You can either write those yourself or take it from ChatGPT. I guess you had a session or not. So I'll just now move to basically 8051 microcontroller. Just give a minute. Okay. So before I move, okay, yeah. So I guess we have some time, right? So now I'm coming to 8051 microcontroller. So I'll just quickly go through this as well. I hope SIM 8085 is clear to everyone. In case there is a doubt, you guys may ask. 1 second. The mouse. I guess, yeah, Garima ma'am can share it with you. Okay. Yeah, so 8051. So, okay. Yeah, so 8051, the name of the simulator that we'll be using is EdSim51. So a bit advanced or to what we use. So in EdSim51, we get different peripherals like LEDs, switch. It is having a very basic interface. If you compare it with, I guess you had a lab on Tinkercad, right? So in comparison to that, it is having a very simple interface, but you can basically interface different type of peripherals in it. You can interface LEDs, switches, you can interface 7-segment displays, LCDs, those all you can basically, they have given you an option to just integrate it with the microcontroller and write different type of programs.
This is online.
No, this is offline. After just going through this presentation, I'll let you know how to download it and install it. Then we'll take a break. Then we'll move to the next session. Okay. Yeah. So why we need to microcontroller? There is nothing, I guess, without microcontroller. We all know it. Everything is having a microcontroller, right? Without microcontroller, I guess we can't even imagine our life. So how do we from designing perspective, we decide which microcontroller to use. So these are a few of the factors we basically consider if we are developing a real life project, right? So I've worked in the industry for a very long time. Not a very long time compared to all of you. Sorry to say that, but yeah, it was a very good experience working over there. I've worked in the development of electric vehicle charging stations for about 3-4 years when EV was a very new thing to India. So my company was the first one to develop it in India, to introduce it in India. So I worked on that. That was my first project, by God grace. So how you decide which microcontrollers to use? Speed is one of the important factor. Same thing we need to communicate to our students as well, because what student does is they make some awesome projects, right? They build some very awesome projects, but when they move to the industry, they don't have these kind of knowledge. Like they know, yeah, I'll integrate something, I'll if talking about some basic things, and I'll just open some doors based on some sensor, but they should also have an idea, like when they are working in industry, then even 1 rupee or 1 paisa matters to the company, because they are working in very bulk. And 1 microsecond, like if I am talking about the defense sector, timing is very important. Reliability is very important. So these are a few of the things that we like consider while using a microcontroller. Speed matters a lot. Power consumption matters a lot. Nowadays, most of our projects, if I talk about defense, so they are implemented in some remote areas where there is no power. Basically, we power it using some solar modules. So power matters a lot. Amount of RAM, ROM, memories, IO pins, cost per unit matters a lot. Packaging is basically the size of the microcontroller, because size of the PCB or the system which you are developing also matters a lot, specifically in case of aerospace application, I would say. Okay. Yeah, so different type of tools we have: assemblers, debuggers, compilers, emulators, simulators, we have them. So now moving to 8051, right? So what it is having, same sort of a thing as 8085. I won't tell you the difference. This every teacher asks to every student, I guess, while giving a first lecture on 8051. So the features for 4K bytes of ROM, 128 bytes of RAM. Then we have 4 IO ports named P0, P1, P2, P3. So these ports are basically used to integrate different type of peripherals to the microcontroller. Like in case of Arduino, you would have seen there were some digital pins, some analog pins. So same sort of things are there here as well. We have some timer counters, right? We have some serial interface. This is the block diagram. Okay, so CPU, the brain, then you have some interrupts, oscillator to give the speed, right? Some bus control, some memory, some timers, some serial interface to interface some serial devices, some IO ports, input output ports to basically connect some devices to it. Some features, it is having 1 on-chip oscillator, external crystal, some interrupt sources. I guess I'll just move through that. This is the schematic. So we have some crystal connected to it. We have some ports, P0, P1, P2, P3, right? So you can connect some data to it. So AD means this port works as an address bus and a data bus. This P3, we can connect some devices to it. It is having some additional control function as well: read, write, timer, T1, T0, interrupts, transfer and receive functions for serial data. So port is the important thing in case of 8051. So port refers to a group of pin where you can connect some devices, right? So yeah, so microcontroller basically uses them to monitor or control some other components or devices. The device can be some sensor, the device can be some switch, some device can be something you want to drive, a motor, anything you want to drive, a relay, right? So these are the ports: P0, P1, P2, P3. I have already told it. So alternate functions, the alternate function of P3, yeah, port 3, receive serial data, receiving and transmission, external interrupts, timers, so read and write. Okay, so this is somehow it works. So those who want presentation, we probably can share it, hopefully. So crystal connections, yeah. So same addressing modes is what we'll discuss. Just move to that. Okay. So yeah, so we have 6 addressing modes: direct, indirect, register addressing, register specific, immediate addressing. Let us just discuss all the addressing modes one by one to have an idea about the programming. So direct addressing mode. In this, one second, okay. Yeah, direct addressing mode same as that as 8085. So we are basically mentioning the memory location in which the data is stored. We are just taking the data from memory location and moving it to some register. Indirect addressing mode. So in this mode, the instruction specifies some register which contains the address. So same was the case in 8085. Suppose, yeah, so how we write it? We write it this way: move a, @R1. So whatever the memory location is stored in R1, it will take the data from that memory location and stored in accumulator. So only R0 and R1 can be used, okay, for this type of addressing. Then we have register addressing mode, same as 8085. So we are mentioning some register like move R2, A. So moving the data from accumulator to R2. Immediate addressing mode, directly mentioning the data, right? We mentioned hash. So suppose I write move a, hash 30h. So this will move 30 into accumulator. But if we don't use this hash, it will take it as a memory location. All right, so I guess some instruction sets are there: arithmetic, logic, data transfer. So different type of location are there. I am not discussing it. So now you guys can read it. There are, I guess, books available for that. So I am just closing it. So the simulator that we are using is called EdSim51. Just write it on Google. So this is not an online simulator, but you need to download it. It is a Java-based simulator, but you need to write is EdSim51. I would like all of you to write it, as I want you guys to download it before we start the next session.
First one.
Yeah, so this one. So once you click on this window will open. Just once you click on this, so the download page will come. Just click on the download. Once you download it, let me just download it. Yeah. So a zip file will get downloaded. This is the zip file which will get downloaded at EdSim51. So version as of now is 2.1.38. Should I? Yeah.
Just right click.
Yeah. So just right click on it, but move to the folder, right click on it and click on extract. Yeah, extract all. Okay, so this is the folder which you will get. I'm just moving. Yeah, so this was a zip file which got downloaded. I've extracted it. I've got this. So one thing to notice is just close the window and open it in downloads. I guess that will be good. Extractor has, I guess, opened it directly. Just minimize it. Open my computer and downloads. Yeah. So once you click on it, just right click and extract. Yeah. So one thing, I'll just give you some time to extract it. Just right click on it and press extract. So next thing what I was saying is, what you need to do is, this application basically works on Java platform. So most of the systems are having Java installed, but those who are not having it, just search download Java. This window will come, download Java for Windows. You just need to click on this, download Java. And once it gets downloaded, this is what will come. And just install it. I'll just.
ये download जाओ तो desktop से.
हाँ.
ये
Yeah. This yeah. So you have extracted it. This is the folder which will come. I guess this is already having some Java is not installed. So you need to download it. Yeah, it works on that. You need to install Java. And you downloaded it? Sorry?
downloading installation complete.
Just what I'll do is I'll just wrap up the session and I'll just wrap up the session. Okay. So I guess you all have installed Java. So just double click on it, the downloaded file. Click on yes, and it will just install the Java in your system. Okay, you just need to install it. I've already installed it, so I won't. Okay. So once you install the Java, just go to that folder, open it, click on this edsim51di, and there is a executable jar file. So you just need to double click on it, and this will open.
Open clear.
I'm just just a minute. Yeah. So once you have extracted the file, this folder you will see, double click on it. Again, double click on edsim51. There is one folder called library, and this is the file that you need to open. Just double click on it, and this will open. I guess it is open. So before wrapping this session, I'll just tell you a bit about this, the interface. I just want you to have a look on the screen for just 5 minutes. Okay. Yeah. So this is where we'll be writing the program, right? So these are the various registers R0 to R7, which you can modify same way 05, pressing enter, it will get modified. Okay. So B accumulator program status, but there are some additional registers here in 8051. So those are also available over here. So you can modify them as well. 03 or whatever you want. Okay. Then these are the timers, TMOR, TCON. You guys can read about it. Whatever the frequency you want to have. Like in real world scenario, what you will be doing is you'll be changing the crystal which is connected to 8051. But here you can directly change the frequency, system clock basically. Same here we have having two memory, data memory and code memory. So this is the data memory. Suppose I want to modify this location. How I will read it is 21. Suppose I want to change the date of 21. I'll write 21 in the address and the value that I want to have. Suppose I want to have 05. I'll just press enter and this will get changed to 05.
How's it?
Suppose I want to change the location of this 30, 3 and 0. This is how we'll read it.
30.
So I'll write 30 in the address bar. The data that I want to have 02, I'll click over here and press enter. So this will get changed to 02. Everyone can check. Okay, yeah. So whatever whatever location you want to modify, suppose I want to modify 10, yeah, or 11. 1 and 1. So I'll write 1, 1 in the address bar and write the data F1 in this. So it will get changed to F1. Okay. So these are the memory location and the registers. This is the location where we write the programs. So these are the peripherals I was talking about. It looks a bit simple compared to Arduino or Tinkercad, but is having the like most of the basic peripherals that we used to connect earlier in our college days, or which we might be connecting these days as well. So these are the LEDs. It is having 8 LEDs. It is having 8 switches numbered by 0, 1, 2, 3. Okay. So if you want to click, if you want to turn a switch on, just click on it. It will get turned on. Just click on it again, just to turn it off. Then we have a digital to analog converter, DAC. Okay, so you can watch its or see its data on oscilloscope as well. They have provided oscilloscope. Then we have a keypad. We have some 7-segment displays, 4 number of 7-segment displays. We have a serial port to send serial or receive serial data. We have analog to digital converter. So you can change the data. Then we have a motor connected to it. How do we know it is connected to which port? There are 2 or 3 options to see. One in this window. One thing I don't know why they have not done it. You can't zoom it, and I don't know why they haven't put this much intelligence in it. But you can't zoom in. Okay, so this is an issue. Okay, nothing can be done. I'm really sorry for that on their behalf. Okay, so if you click on port 0, this is port 0. Once you click on it, it will display which pin of port 0 is connected to which pin of a peripheral. Suppose port 0, pin 0 of port 0 is connected to keypad row 0, then keypad row 1. So you can just check which pin is connected to which pin of the micro port, right? Similarly, if I click on port 2, then we have switch 0, 1, 2, 3, 4, up to 7 connected to port pin number 0, 1, 2, 3, up to 7 pin of port 2. We have ADC connected to port 2, right? Talking about port 3, we have ADC, motor sensor, some gate, ADC interrupt, motor control bit connected to port 3. Okay. Now, if suppose this is tabular form, you want to see the circuit, then there is a button over here which is called as logic diagram. Once you click on it, you will get the logic diagram. Suppose, and what you can do is you can either connect or disconnect all of these. If I click on deselect all, everything will get disconnected. You can see the lines got faded away. If I select it, it gets connected again. Suppose I don't want to connect everything. I want to connect LED bank only. Just click on LED bank. The LED wires will get connected to port 1. So this way you can have a pictorial view of how the connections are being done. So if I talk about LED, then LED 0, the P side is connected to V plus, positive, and the N side is connected to the port. Suppose I want to make an LED glow, then I would need to provide a logic 0 in order to make an LED glow. 1 second, let me check. I guess we have some message. Yeah. So what we'll be doing is we'll just have a 15-minute interaction session at the end. Parallelly, you can also ask questions, I guess. Right. Okay. 1 minute. Let me just check. Schematic opening. Okay. I'm just closing it again. So this is the window which gets opened. You just need to click on LD. This opens the line diagram for you. Whatever you want to connect, you can connect over here. Okay. I guess what I last thing before wrapping up the session, how do you change the connections? Then there is a button called DI, dynamic interface. Okay, so there they have provided it the option to change the connection. Suppose LED 1 is now connected to port 1, pin number 1. So you can just click on it and select which pin you want it to get connected to. And just save it, reopen the file, and the whatever the change will take place. So you can change the connection as well.
Port assignment also can change.
Yes, you can change the port assignment. Okay. So I guess this is a brief about the interface, right, of this simulator. So now I guess we'll just take a break. It has been a very long session, and we'll just connect it again at 12, I guess. Yeah, right. So thank you so much, everyone. Meanwhile, what I would like you to do is just install the simulator for those who haven't installed it, and then we'll just write some programs to interface some devices to be aware about this 8051. Okay.
लास्ट में क्या दिखाया था?
ये आप चेंज कर सकते हैं यहाँ पे बेसिकली इफ यू कनेक्ट ऑन DI तो आप पोर्ट असाइनमेंट चेंज कर सकते हो किस पिन को किससे आपने कनेक्ट किया हुआ है. So if there is any question, I guess yeah, right. So we'll just connect at 12. So looking forward to see you guys again. So.
और ये अपनी टॉयलेट है, अब यहाँ पे मत रखना। कैमरा चेक कर देगा सामने।
Hello, hello, hello.
Dr. Nalish Sharma, do you have any query?
Coffee this. Hello.
Hello everyone.
Audible, sir.
I guess my voice is audible. Let's start the next session. I hope you all would have. So I hope you all would have already installed EdSim 51. So we are just about to begin.
Good afternoon, sir.
Hi, good afternoon. Just a second.
Okay.
So I have my screen. I hope my screen is visible to everyone.
Yes, sir.
So did anyone had any difficulty installing it? I guess if there is any, you guys may just let me know. I'll just solve it. Okay, so let's begin. So I'm just quickly recapping. So this is the programming window. Okay, so these are the registers with which we'll be playing. Right. So here we have the data memory. We can modify it as per our need. Then we have some peripherals over here. Right, switches, LEDs. So we'll just interface few of these. Here we have the connection details for various peripherals. You can open the logic diagram, line diagram basically from here. You can either connect or deconnect as per your requirement. So I've connected all. In order to modify the connections, you can just click on this digital interface, dynamic interface basically. So you can just change the connection of whatever peripheral you want to change. In order to change the connection, you need to first save it and then restart your application. Okay. I guess let us begin with some basic programs in order to have some idea about various type of addressing. Then we'll just quickly move on to interfacing some of the peripherals. So we can start with some, I guess, a basic addition program only. It won't take much time. So same is the case over here. In order to write a comment, just you need to use a semicolon. So I'm just doing an addition program. Right. So there were various type of addressing which we were supposed to do. Let us do first immediate addressing. So suppose I write move R0. So in order to do immediate addressing, in which we basically specify the data directly. So we need to use hash, as I told earlier. Zoom is a problem in this application. I'm really sorry for that. 1 second. Just a second. Let me just. I guess it is fine now. Okay. So there was a button. Okay. They are not that stupid. So move R0, 20H. Right. So what this will do is move 20H into R0. Right. So this is what you call immediate addressing. Okay. Similarly, this was immediate. Suppose you want to move now let us do register addressing move A, R0. So this is move data from R0 to A. Right. So this is register addressing. Right. Let us do an indirect addressing as well. Move A, @R0. Move data from memory location in R0 to A. This is what we call indirect addressing. Any address you can. I'm just taking a random.
You have mentioned R0 already 28.
Yeah.
28 value we should.
So right. I'm just ending the program. 1 second. Halt. Okay. So this is immediate addressing. What this instruction will do is this will move the data 20 into R0. The second one is the register addressing. This will move the data from R0 to A1. So after executing this instruction, R0 should get moved to A. Then the last one is the direct addressing. So what this will do is this will basically take the memory location in R0 and move data from that. So after executing this, the data in R0 will be 20, right? So we need to move some data in 20 to check whether it is working or not. So in order to modify the address, you need to write the address over here. And whatever value you want to have it, 1A, I want to have 1A. 1 second here. Okay, so now 20 is having 1A. So this is basically jump instruction, short jump. So I'm just ending the it will keep jumping over here. So there are various methods to end the program. I've just written it. Okay. So now let us, so what you can do is, suppose you have written a program. So I've forgot to mention about it. You can save the program in your system. Suppose you want to save it. You can just click on save and save wherever you want to save a program. Suppose you want to have some demo programs we want to teach to your students. So using this, in case of online simulator, you have to write the program again and again whenever you are basically working on it. So as it is an application, you can just save the program and just open it, load it again. So wherever you want to save. Okay. So I've written the program. Now this is the assembly. Now I have assembled it. When you assemble it, so if there is any error, it will highlight. If you click on run, same as it was in case of 8085, if you click on run, all of the program will get executed at once. But after assembling, if you want to debug it, check step by step. So there is a button called step. So this will do step by step execution of the program. Okay. So 1 minute. Okay. Just a minute. Yeah. So, right. So let us assemble it. I'm doing step by step instruction. So first execution. So what it will do is it will move 20 into R0. You can see after executing it, R0 got changed to 20. Next is move data of R0 into A. So now A should get changed. Accumulator here got changed to 20. Next is move A, comma @R0. So the memory location pointed by R0, which is 20, data from that, which I have preset it as 1A, will get moved to accumulator. Now you can say, now you can see accumulator is having the data 1A now. So we have used 3 types of addressing over here. Rest we'll do as we write some programs. So this is just to get hands on this simulator with respect to the programming. Okay.
To clear that windows.
Yeah. So in order to stop it, just click on reset. And just select it and click backspace. Okay. Okay. So let us do a simple addition program. Okay. Okay. So let us take data from 2 memory location, 20 and 21, add it and store it somewhere. Okay. So I'm just removing the line. I'm just doing some, yeah. We also will be, just a minute, let me check if there is a question. Yes, all right. Yeah. I'm just removing this. Okay. So what we'll be doing is we'll be adding two numbers. So first number we'll take from 20. Okay. Let us initialize another memory location. 30 is what we are taking, comma hash 30h. I'm just changing the comment as per first memory location is 20h. Second memory location is, yeah. And let us have a register for carry as well. Move R4 hash carry. Yeah. Or what we can do is 03 and 05 over here. Let us do one thing. Let us do it in the same way we did for 805. So this is the location for the result location. Okay. So what we'll do is we'll take the data from 20 and 21, same as we did for 8085. Okay. So I guess it is clear up to this line. So what we are doing is we are taking the data from R0, 20, basically 20 into accumulator. Now we'll take the data from 21. So the instruction is INC R0, increment data in R0. So after this, the data of R0 will get changed to 21. Here it was 20. It will get changed to 21. Move it, come on. Okay. Move a comma at the rate. Now as we have incremented it, we'll take the second number into R0, but before doing that, we'll store the first number in some other location. Move R5. Comma A. Move first number to R5. Okay. I'll just explain it again once I execute it. So up to now what we have done, carry we are storing in R4. For memory location, we have two memory location 20 and 21. So the first number we'll take from 20. So we have stored that into R0. The result we'll store it in 30 location. So we have moved it in R1. The first number through indirect addressing, we took it into accumulator. We moved the first number into R5. Then we incremented R0, so which will change to 21. Then we are moving the data, the second number, take second number in accumulator. Now add A comma R5. Add two numbers. Now we'll check for carry. After adding the two numbers, we'll check for carry. We'll move to some location called save. Move. Yeah, so we will basically, I'm just give me a minute, move carry to R4. Or yeah, move, just give me a minute. R1 comma B INC R1, move add that R1 comma A. Okay, INC R4. I guess it is clear now. So I'm just explaining it again. So initialized for carry. So what we are doing is we are taking two numbers from 21, 20 and 21. I should say it like that. I'm storing the carry in location 30 and result of the whatever the summation we are doing in 31. Okay. So I initialize two memory locations. Okay. So the first number we took into accumulator through this indirect addressing. We moved the first number into R5. We incremented R0. We basically are changing 20 to 21. Then taking the second number into accumulator, adding both the numbers. Result will be stored in accumulator. Checking for carry. In case there is no carry, we need not to increment. In case there is no carry, we just need to skip the part where we are incrementing R4. Directly, we are saving the carry in. Yeah. Is there any doubt? Okay. Yeah. So what we are doing is, firstly, R4 was supposed to have carry. So carry we have stored in B. So B we are moving to @R1, which means 30, the memory location pointed by R1. Then we are incrementing R1, changing it to 31, storing the result in 31 location. I guess it is clear or not?
21 में क्या देखा सर ने 21 में कुछ भी ऐड करना है
ये है ना, ये 20 है, ये 21. मैंने दो नंबर लिए हैं बेसिकली. मैं एक बार एग्जीक्यूट करता हूँ, इट विल गिव अ बेटर आइडिया. इनको मैं 0 कर देता हूँ कुछ चीजों को. जस्ट गिव मी अ मिनट. 30. Just give me a second. Let me just make. Okay. Okay. So initially, all my memory locations are 0. Okay. Yeah. So what we are doing is we were having two numbers. One number was in 20 location. Another number was in 21 location. Okay.
yes.
So let us just assemble it first. Okay, I'm doing step-by-step execution. So we wanted to store carry in R4. It could have been any register. I'm storing it in R4. So I don't know what the data is there in presently in R4. So I'm just moving 00 to R4. Okay. Now the first memory location is 20. So I'm moving the memory location into R0. Now R0 is having 20. I could have done direct addressing as well. I'm just doing indirect addressing in this, which made it a bit complicated. Otherwise, I would have written move a comma 20h. So it would have moved the data directly. So yeah. Next is move R1. So move data 30 in R1. Okay, now R0 is having 20 and R1 is having 30. Okay. First, what we are doing, move a comma @ of R0. So it will check the memory location in R0, which is 20, and move data from that, which is 03 into accumulator. You can see now the data is changed to 03. Now we are moving the data of accumulator into R5. So 03 got moved to R5, as we need to move the next number. Now we are incrementing, as the next location was 21. If it would have been something else, then we would have done like move R0, comma 05 h, whatever the location would have been. As the next location is 21, I'm incrementing it. So now R0 got changed to 21. 21 is having data 05. So we are moving the data from R0 into accumulator. Now accumulator got changed to 05. So this was our first number which we moved from this location. This is our second number which we moved from this location, right? Now we'll be adding both. 03 plus 05 is 08. Now we have the result. Now we'll check for carry. In case there is carry, we will increment R4. If there is not, we'll just skip it and jump to this location. So in this case, there was no carry. We directly move through this. R4 is still 0. Now we'll move R4, the carry in B, 0, it got 00. Carry got stored in 30 location, which was R1. the second numbers in the same way got stored in 3, 1. We incremented it, and so 0, 8. The result got stored in 0, 8. Basically 3, 2, 3, 1 location. I hope. Is there any doubt? I can explain it again. अच्छा मैंने हाँ actually what I would have done is इधर मैं कर देता है okay ये कर सकते हैं हम let me just make it a bit linear. ओके मैं अभी इसको रीसेट कर देता हूँ. ये थोड़ा सा इमीडिएट की वजह से इट गॉट कॉम्प्लिकेटेड. Okay, I'll just execute it again. R4 is changed to 0. Okay, I executed it at once. 1 second. Just give me a minute. Okay. Okay. So first of all, R4 will get 0. R0 will change to 2, 0. We have 2, 0 over here. First number through indirect addressing, we are taking, which is the data in 2, 0, we are taking into accumulator. 0, 3 now got moved to accumulator. Now this accumulator data will move to R5. Okay. Yeah, now we will increment as the next number was in 21. So we'll increment R1, which will get changed to 2, 1. It got changed to 2, 1. Now the data from next memory location, which is 2, 1, which is pointed by R0, we are taking into accumulator 0, 5. Now we are adding both the numbers 0, 5 plus 0, 3 in hexadecimal, it is 0, 8. No carry, we'll check for carry. As there is no carry, it will directly move to save. Now we want to store the sum in 30H. So we will move 30H to R1.
No, that will be directly. R1.
I'm now doing the indirect addressing.
But directly move R1 as 30H. It will go to directly 30H will be stored in your R1.
I'm pointing to the memory location pointed by R1. Now R1 is having 30H. I wanted to store the data in 30. Now if I execute it, 30 will have 0, 8. I did an indirect, that made things a bit complicated, but let's move the code. I could have directly mentioned the address as well, but I wanted to do indirect addressing. If I would have just written,
Instead of that, you can write directly 30H, it will go to large location.
I just wanted to go through it. If we are comfortable with this, we obviously will be comfortable with that as well.
इंक्रीमेंट R1 के लास्ट से
हाँ इंक्रीमेंट अब हमें कैरी भी स्टोर करना था तो अगर सपोज मुझे कैरी किस 40 में करना होता तो देन आई वुड हैव रिटन दिस मूव R1, 40 if I wanted to do this way. मैंने 3.1 में करना था तो rather than writing this big instruction again I wrote INC R1. So this will change R1 to 31. अभी तो carry नहीं है, carry is not there, तो 31 will be 0 only. Suppose data was, let me just reset it. Suppose data in 20 was FF. Okay. Abhi if I would have run it. Just a minute. R4. R1. Okay. B. I missed the line.
Yeah.
Move up. I'll just write it this way. Yeah. Right. Move carry to B. Now carry 0, 1 got stored in 3-1 memory location. I missed a line.
B should be ended with semicolon. That bottom instruction.
Yeah, you need not to write semicolon. Semicolon is only to write a comment. If I don't write semicolon, this will work properly.
Line is simple.
Semicolon basically denotes whatever you're writing next to it is a comment. Okay, I guess Abhi, I can explain it again if you want. What I could have done is, just to make things a bit clear, what I could have done is I could have stored the carry. Just give me a minute. I could have stored the carry in some other location. 4-0 maybe my store, I could have stored it. Abhi it will get stored in 4-0. Multiple ways of, if the location would have been different, I couldn't have used, like that would have not been feasible to use INC. Right. I guess the rest of the programs you can do, let us just interface few devices. Online also, hopefully. Okay. Yeah. I guess online also you would have executed this. You can take a snapshot, or this is just a basic program. You guys can try it just to give an idea of the interfacing. Okay. Right. I'm just deleting this. What we can do is we can LED. Okay. Let us interface some LEDs. LED interface. Okay. First of all, in order to interface the LED, we need to know where the LEDs are connected. So I'm just connecting the LED bank, or you can collect every. So LED 0 is connected to port 1, pin 0. So LED up to LED 7 is connected to that only. Okay. So now the thing is, if you see LED is already connected to plus VCC. If you need to make it blink, so you need to move 00 to port 1. Yeah. So you need to have logic level low on port 1, which will make the LED glow. And if you want the LEDs to get off, you need to move a logic high 1 into port 1. So I'm just connecting everything. 1 minute. Okay. So suppose I'm normally writing move a comma hash 00h. So this is to what I'm doing is, as I need, in order to make all the LEDs glow, I need to have 00. If I convert it to hexadecimal, it will be 00000000, right? Move 00 to A. So then I'm moving that data to port 1. So this will turn LED on. LED. Yeah. Yeah. So I'm just, let me just turn it on once. Yeah. So once I assemble it and run it, so all the LEDs got turned on. Right. So why did this turn on? Because if you see the logic diagram, this is also connected. The 7 segment is also connected to this pin only. Just a minute. Where is, yes, as this port is also connected to. Yeah. Okay. Right. So this is the way to turn on. So this is turning on all the LEDs. Suppose I want to turn any 2 LEDs. I want to turn LED 0 and 1. Okay. So in order to write it in binary, it would have been 1 1 1 1 1 1 0 0. So I'm providing logic high to port. Yeah, in hexadecimal I'm writing it. So I would have binary basically. So I would have given 0 0 to 2 ports, pin 0 and 1, right? So in hexadecimal it would have been F8 and FB. Okay.
Instead of directly you can push immediate value.
Yeah, we can do that as well. FB. Okay. F, yeah, was it B only? I guess it will be 1100.
No, you have just put as a 0 and
C, sir, C.
C, it will be C. No, yeah, one thing I would like to tell, if you're writing a number like F, the first digit, if it is a character, then you need to write 0. FC, it will be FC.
Yes, sir.
Yeah,
FC is it?
I'm trusting you on this. Yeah, okay. So now 2 LEDs are glowing. And accordingly, 7 segment, those LEDs of 7 segment is glowing. Similarly, suppose I want to, just to have an example, I want to glow only last 4 LEDs. So it would have been F0. Assemble and run. So yeah, now only the last 4 LEDs are glowing. Okay. Okay, I guess. Now suppose we want to blink the LEDs. So what we'll do is we'll turn on LED, wait for some time, turn off LEDs, wait for some time, as you would have done in Tinkercad. So this is the function used for calling delay. I could have written anything over here. I'm just calling. So this is used to call a function. A call. There are various functions for calling as well. Yeah. Yeah. So whatever you want to write, you can write over here. I could have called it something else as well. So calling delay. Okay. So here I turned on all the LEDs. I'm just copying it over here. Now, after the delay, I'll move FF. This will turn all the LEDs off. Again, I'll call a delay. The same delay. You can have a different delay as well. Call delay, right? And what I want to do is I want to repeat this program again and again. So I'll do a jump to some location called start maybe, okay? And I'll write start over here. So up to now, LEDs will turn on. By this, we'll have a delay. Then LEDs will turn off as we are moving FF to it. Then there will be a delay and it will jump back to this location. So this will keep rotating. Yeah, this is unconditional jump. So we don't need this. Now we need to prepare a delay program. Yeah, subroutine. So now we are preparing a delay subroutine. So the same name which I have given over here, I need to give here. So there are various methods of writing a delay subroutine. So you basically need, you can do a,
some value.
Yes, you can directly assign some values. You can use some timer, whatever you want, you can use that. So what I'm doing is 01H. I'm moving. So yeah, just loop. Let me just explain it. Okay. Yeah, so this is the delay program I've written. So what I've done is I've just moved a number 01H into R7. So what I'm doing is jump on 0. What it does is whatever the register that you have written over here, it decrements that register by 1 and it checks whether that register got 0 or not. If there is no 0, it will again, it will basically keep repeating it again and again. If it gets 0, it will call the return function. The program will get returned to the next line where you have called the delay. So let me just assemble it. So now you can see getting turned, the LEDs are getting turned on. There is a delay, right? Then we are turning off the LEDs. Then there is a delay, just repeating the same again and again. Suppose I wanted this, I have written it as 1 only. I wanted to increase the delay, I would have written 0, 2. Then it would have taken more time, or you would have updated the frequency, the speed of execution of the program. But in practical scenario, it is not very feasible to change. Now there will be a like double the delay but of what we were giving earlier. So this is a basic blinking program. So in the same way, I won't tell about 7 segment. I guess 7 segment in order to for working on a 7 segment, what you need to do is you need to, suppose I want to make if I want to display number 0, then what I will do, whatever the pin is connected to the center LED, I won't make that glow. I want
This one is the active low.
Active low. Active low. Suppose I want to give 1. So just give me a minute. Yeah. So here you can see which pin is connected.
G pin.
I can check it over here as well. Yeah. So suppose I want to display 1. I'm just checking the logic diagram. So B and C I need to glow, right? So B is connected to P1.1 and C is connected to P1. Well, the pin number 2 of port 1, right? So here what I need to give is 1 1 1 1 1 0 0 1. बेसिकली मैं अभी किस चीज के बारे में बात कर रहा हूँ, हम इस पे 1 डिस्प्ले करना चाहते हैं सारे एलईडीज ग्लो कराने के बजाय. तो फॉर दैट I'll just go to the logic diagram. यहाँ पे logic diagram में they have given the 7 segment display pin. So in order to display 1, मुझे B and C को glow करवाना है. I need to make pin B and C glow, right? Right. So the logic level of pin B and C will be 0. क्योंकि ये ऑलरेडी हाई से कनेक्टेड है, प्लस VCC हमने दिया हुआ है. रेस्ट ऑफ द पिन्स विल मेक हाई. अब ये किससे कनेक्टेड है, यू कैन सी फ्रॉम हेयर. यहाँ पे दिया है पोर्ट 1 के B and C is connected to pin 1 and pin 2, segment B and segment C. So we need to give 0 0 to these 2 pins and 1 1 to all of rest of the pins. So if I write it in binary, so it will be 1 1 1 1 1 0 0 1. Converting it to hexadecimal, it will be F8 and 1 9, F9, right? So suppose if I would have written F9 over here, now 1 is displaying in the 7 segment.
बाइनरी में भी डायरेक्ट डाल सकते हैं.
नहीं आपको हेक्साडेसिमल में डालना है. Right, same is the case for 2. Any number you can, as per your requirement, you can just display over here, right? You want to have a timer 0 1 2 3 4 5 6 7 8 9, again resetting it, so the program will be that much lengthy. Accordingly, you can just interface it. You can just try it once. Those who want to write just can check. I would say just try displaying number 0. You can try. आप एक बार 0 number 0 को you can try displaying. If there is an issue, then 0 के लिए what you need to do is
First one is 0, all are 1.
all, yeah.
First one is 0 and all are 1.
Anyways, you can do it. You can instead of, yeah, what you can do is display 0 then 1 then 0 then 1. This way also you can do it. इसमें आप क्या करेंगे, द फर्स्ट सब रूटीन दैट यू आर राइटिंग, दिस वन, आपको कौन कौन से टर्न ऑन करवाने हैं, आई एम जस्ट ओपनिंग दिस विंडो. टू जी एंड डीपी यू विल गिव 1 1, rest of the pins you'll give 0.
G first में G.
हाँ जी. So ये रही आपकी port details भी. I'll open the port details. So in order to display 0, G and DP, this you need to make 1 1.
Port detail कहाँ से open किया सर?
ये यहाँ पे दिया हुआ है, साइड में ही आपके इसमें. So you will be giving 1 1 0 0 0 0 0. Program also I'll open over here. 1 1 1 0 0 0 0. देखिए मैं
ये पोर्ट 7 इसकी G जो है वो 6 में open है.
हाँ जी, ये हाँ G is 6 है ना.
तो 1 0
एंड इसको भी करना है आपको डीपी. ये डॉट भी दिया हुआ है ना यहाँ पे, इन्होंने डॉट का भी दिया. दिस इज द डॉट. इट डजंट मैटर, मतलब इफ यू वांट टू रिमूव द डॉट एज वेल देन यू विल राइट 1 1, मतलब यहाँ 1 यहाँ 1, रेस्ट 0 0 0 0 0 0. तो 1 1 will be 8 and 4. C I guess C. तो you will give C.
C0.
तो यहाँ पे आप C0 लिख देंगे और 1 डिस्प्ले करने के लिए F9 हमने अभी बनाया ही था.
तो F9 कहाँ डालेंगे?
जैसे सपोज यू वांट टू डिस्प्ले 0 फर्स्ट, आपको पहले 0 डिस्प्ले करना है, यू विल राइट दैट हियर. आफ्टर दैट यू वांट टू डिस्प्ले 1, तो कोड फॉर दैट यू विल राइट आफ्टर डिले. अब जितने नंबर आपको डिस्प्ले करने थे ना, सपोज यहाँ तो 0 कर रहे हो फिर ऑफ कर रहे हो, मतलब ये वाला जो प्रोग्राम है ना, इसमें तो 1 कर रहे हो, इस प्रोग्राम में 1 हो जा रहा है यहाँ से यहाँ तक, और फिर
डिले के बाद चेंज हो रहा है.
हाँ डिले के बाद चेंज हो रहा है. अभी हमने क्या बनाया
कॉपी करके उसके नीचे डाल दीजिए.
हाँ जी, ये देखिए जैसे सपोज यहाँ था C0. तो हम क्या कर रहे हैं, इसमें डिस्प्ले कर रहे हैं 0 को. ठीक है, अब हमें डिस्प्ले करना है 1 को. तो ये इट वाज F9. F9 it was F9. ठीक है, सेम सपोज यू वांट टू इंक्रीज इट, यू वांट टू डिस्प्ले 2. You will display A, B, G,
D,
E, D.
D.
F and C you need to make off. F, C and DP. Okay. F, C and DP. So I'm just writing over here. DP is off. F and C. Okay. Rest will be 0. This will be 0. F you want to turn off 1.
Yes. And C.
0, E, D also 0, C 1, and B and A. So this will be 8 and 2. A
4.
Yes, it will be A4.
For 2.
Yes, A
0 A2.
yes. Now if I assemble it and run it, 0 1 2. हमने सेंटर का I guess we have missed 1. Okay, oh sorry.
यहाँ नीचे लेके आना होगा.
0 1 and 2. Yeah, 0 1 2. So this way you can, अब suppose you I want to display 1 2 3 4, तो आप चारों segments को भी enable करके,
क्या था सर इसमें कि क्यों 0 और 1 ही क्यों आ रहा था?
वो एक्चुअली मैंने क्या किया था, ये कॉपी तो कर दिया था प्रोग्राम, ये एस जंप स्टार्ट को यहाँ कॉपी कर दिया था, तो 0 1 यहाँ पे करने वो पहले ही जंप हो जा रहा था.
तो सर इसमें हम सब रूटीन कहीं किसी और लोकेशन पे स्टोर करके बार-बार
बार बार, हाँ, क्योंकि वही अगेन द सेम थिंग, वो राइटिंग द सेम थिंग एंड अगेन मेक्स द प्रोग्राम कॉम्प्लिकेटेड. अब ये आप डिले प्रोग्राम को बहुत तरीके से लिख सकते हैं, है ना? तो दिस इज वन ऑफ द वे. I guess if there is any doubt, you guys may ask in the online session. You guys can write and just try it.
डिले के लिए अगर डायरेक्टली नंबर देना हो तो
There is a way of doing it. आप देख लेना वो नेट पे various ways are there. आप कर सकते हो, कोई इशू नहीं. I guess we can move on, है ना?
Yes, sir.
So if I want to save it, I'm just doing a suppose you want to save it somewhere, I guess on the desktop. So you can save it as assembly program, and you can use the same program in your actual kit as well. Okay. So this LED blinking or 7 segment. So this will get saved. Wow. So this is .asm. This is an assembly file. So you can use it wherever you want to, and you can load the same file in this simulator as well in future.
Sir, can we convert this to hex file also?
Yeah, hex. They have given an option in here only. You can save as. So there is an option to save it as a hex file as well.
Okay. And then we can upload it to the program.
Yes. You have all the options. Okay, I guess we are okay with it. Now let us just interface some switches. Then we'll move on to some other device. Okay, I'm just deleting it. So if I see the logic diagram, I'm just deselecting it. Switch bank is connected to port 2, right? And LED is connected to port 1. Okay. So first of all, we need to understand the schematic. So if the switch is on, the VCC through this resistor gets connected to the port, right? If the on, I would say off. I should be saying off. If the switch is off, this is open. I would say if the switch is open, VCC get connected to your port, right? If the switch, we close it, so then it gets grounded. Switch, the other end of the switches get connected to the ground, right? So suppose I want like whatever switch is on or is closed, the subsequent number of LED should get on. So what we need to do is what we were doing, we were writing the data in port 1. So here what we'll do is, if it is 0, suppose switch 7 is closed, so we'll get 0 on pin number 7. What we'll do is we'll read the data from the switch and just move it directly to the LED.
Mapping.
Just map it 1 to 1, right? Yeah. So I'm just connecting everything again. Which port was it? Just a second. Yeah, port 2. Okay. So we'll move the data from port 2 into A. This is a very simple program. And move the data from A to port 1. And we'll just execute it again and again to have a real time tracking.
Jump me again. Look.
Now if I assemble it and run it, pressing 0 will turn LED 0 on. Less complicated than the last program. So what we can also do is, same in the case of 7 segment. Suppose someone has pressed switch 1. So the complicated thing we do, then I want to display 1 on 7 segment. Then you'll make it jump somewhere. You basically will compare it with some number and then move to some subroutine. In that subroutine, you will make 7 segment display 1. So that can also be done. So whatever switch you will press, the subsequent LED Yeah, so how it is working is, where is the logic diagram? Suppose we have all the switches are closed, then the value will be 0, 0, 0, 0, 0, 0, 0, 0. We are copying it to accumulator and pasting it to P1. So we'll get 0, 0, 0, 0 over here. All the LEDs will get turned on. Yeah.
Is there any other software for the using Python?
Proteus is a paid one. So there what you can do is you can draw the diagrams as well. So you can do coding in other languages as well. So in the free version, we have this. So this is basically a replica of the kits that we have in our labs. The good thing is here we can change the connections. In the lab, the things are hard code, like hardwired basically. What other program should we do? Okay. Okay. I guess this is clear. Yeah, this was a very simple one. Right. Pause. Reset. Abhi, one thing I would like to tell about the 7 segment. Deselect all 7 segment. Okay. So if you see the 7 segment, all the four 7 segments, they are connected to port 1, right? But if you want, how do you select which 7 segment you want to work on? So there is a decoder which they have connected over here. The decoder pin is connected to port pin number 3 and 4 of port 3. Suppose you give 0, 0 to this. So one A naught, yeah, the display 1 will get, yeah. So this is how you configure which 7 segment you want to basically work on. So you suppose your display is 0, 1, then segment 1, 1, 0 will be segment 2, and 1, 1 will be segment 3. So we are sorted with LEDs, we are sorted with switches, we are sorted with this. Keypad is sort of the same thing. Let me just, then I'll just explain about the keypad, then we'll move to some DAC or ADC. Okay. Yeah. 1, 2, 3, yes, 4. Okay. Right. So in the keypad, in the actual keypad, how it works is they have connected a pin. They work on the row basis. Like suppose there is row 1, 2, 3, 4. Okay. So row 1 takes care of button 1, 2, 3. Row 2 takes care of button 4, 5, 6. So in the similar way, right? This is connected to VCC. Suppose I'm pressing 1. So VCC will get connected to the pin to which this row is connected, right? So suppose we are getting 1 on this pin, which is 3 is pin number 3 basically. Suppose we'll just track it. Suppose I have pressed 1. So that subsequent pin will get logic level high. So this will tell our microcontroller that some button from this row is initialized. Now which button? So 3 lines are there in this. So then we'll track these 3 lines. So a combination of row and column is what we'll use to check which button is glowing. Matrix. So this is how keypad will work. So various type of programs can be done. Suppose someone has pressed 1 on keypad, display 1 on 7 segment. So that depends upon whatever the application that you are having. Now we can move to digital to analog converter is let us check. So these are all just digital input and output thing. So I'm just moving to DAC. 1 second, where is the DAC? Yeah. So here we have the DAC, digital to analog converter. Okay. So the digital to analog converter, all the pins from D0 to D7 is connected to pin number 0 to 7 of port 1. Then
so this AND gate that is given on top of keypad is
just a minute. Let me just check.
It is for transmission.
No, just a second.
Yes, this line.
1, 2, 3.
Enable or disable.
Interrupt.
Okay, no, just a minute. This is for 1.
Interrupt one.
1000. 1 second. 1, 2, 3. 1, 2, 3, 4. Okay, it is working in a different way. So what they are doing is, this is an AND gate. Okay, so various combination of the output, based on various combination of the outputs. So this we are working as an output. This will get turned on or turned off. This will read over here. Based on that only we can decode. You can basically read the circuit. 3, 4, 5. 1 second. That is an issue. 3, yeah. Okay. Yeah, so basically this AND gate will get, I've used it. So the AND gate will get turned on based on the switch that you are pressing. Okay, so suppose there is 0, 0, 0, then it will get turned on and off. Based on that only some logic will be there. I guess you guys can try it and just get to know about it. Next, we'll move to DAC. Here it is. Okay, so the DAC is connected to port number 1, right? Similar way will work, like whatever this is just to give an idea of how the DAC is working. So suppose we get 0, 0, 0 over here. So accordingly, we'll get some analog data. So if all the bits are 0, we'll get 0 and the same will get displayed on the oscilloscope. Okay. In order to enable it, so they have provided pin number 7 of port 0. So you need to give active low, as there is bubble over here. You know? So you just need to give first, in order to use a DAC, we need to enable it. Then we'll give some digital data from here. Then we'll check whether the subsequent analog data is getting displayed or not. So this can be used for displaying various sort of waveforms as well. Suppose you are giving 1, 0, 1, 0. I'm talking in terms of FF and 0, 0. So you can get a square wave, right? Suppose you are incrementing the number. Subsequently, you can get a triangular wave. So different type of waveforms can be generated using this on the oscilloscope. A brief, let's do something. Okay. Yeah, any wave. So that you need to basically work on the digital data. So suppose I'm moving. 1 second. It was port. Logic diagram. Yeah, port 1. Okay. Suppose you want to move 0, 0 to DAC. Now you will write this. We'll call some delay the same way. Let us generate a square wave.
Move P1, comma A, comma A. Solve it. Move A.
So initially I'm moving 0, 0 to port 1, which will display 0. And then I'm moving. So this oscilloscope is having a resolution up to 5 volts. So suppose I'm giving 1, basically FF, so it should display 5 volts. So the formula is normally VCC into, that is a general DAC formula. So delay, I'll write same way I can write. Same way I'm writing the delay. Let me just execute it. So these are also glowing as they were connected, but
03.
1 second, 0 0.
Legends. Roof of light. Or not.
Okay. Why this is not working? Can anyone tell? No. Why we are not getting data on DAC? It is continuously 0. The reason is we have not enabled it. Yeah. So we have to clear the bit P0.7. So that is why it was not working. Pause. Just a second. Yeah. So what I'll do is first enable it. All right.
Clear mode. उसके clear.
0.7.
Clear ना.
1 second.
0.7.
Why is it not working? Clear P0. Just a second. It is returning to the same. Jump to the okay. Stopped. One second. Yeah. So frequency. 1 second. Let me just update the frequency. Now you can see in the DA. So we are getting a. It is basically not showing the wave as the transition very fast. 1 second. Scope. So this is basically the wave. Let me just write some other number over here. 0, 1. If I increase the delay. Okay, so now the square wave is getting displayed over here. So I just increase the delay in the delay function. Otherwise, it was moving very fast. यहाँ पे अभी क्या हुआ when
50%.
हाँ मैंने what I've done is मैंने सिर्फ बहुत छोटा delay दिया था. So when I was running it, so you can see there were very fast transition. बहुत short duration के लिए we were getting high, then low, then high, then low. So I increased it a bit. Yeah. So abhi you can see these are the square waves getting updated in real time.
इसकी सेटिंग कहाँ से करनी है सर?
सेटिंग कैसे?
इसका डिले वगैरह
नहीं ये ऑसिलोस्कोप का तो इस बाय ऑन डिफॉल्ट दिखाइए एक बार. हाँ हाँ इसका ना बेसिकली क्या है ना ये आप थोड़ा सा फ्रीक्वेंसी बढ़ा देंगे ना अब ये बहुत स्लो चल रहा है. अब देखिए अब थोड़ा एक्चुअली आपने क्या किया ना ये 0 0 पे क्यों है आपने 0 0 तो मूव कर दिया. अगला वाले में आपको FF मूव करना होगा. मतलब हाई भी करना है ना उसको, डिफरेंस तो तभी दिखाई देगा। 0 लगाना पड़ेगा। अब आप देखिए तो अच्छा जंप करना, वापस बार बार रिटर्न करने के लिए बेसिकली
इसमें 0 FF है, FF लिखेंगे
हाँ जी
जैसे 0
नहीं वो सिंटैक्स suppose अभी मैं I've generated a square wave. Let us generate a triangular wave. Let us try it. I guess this is clear. I hope. Yeah. In order.
इसमें काउंटर लगा देंगे, काउंटर इंक्रीमेंट
हाँ इंक्रीमेंट वही सेम we'll do some subsequent addition जब तक it doesn't reaches FF, then we'll do हाँ the top, then we'll do in order subsequent subtractions. So yeah,
up to some FF and then we can
move P1. What we can do is add some number, any number, like that depends upon the step that you want to have. Here we'll change it. #0. I'll just explain it. Okay. Move. Just give me a second, just a second. So what this instruction does is, like suppose initially,
it is 0, it will start from 0. Otherwise,
yeah.
FF
So this is a compare instruction. So what we are doing is we are just moving. We were initially having A as 0, so we'll be moving 0 to P1. Then we'll keep adding 0, 3, or it could be any step into A. Then we'll check. Yes, this instruction basically checks whether A is equal to or yes. So till the time it is not greater than that, it will just keep executing it. Once it becomes greater than, yeah, it reaches a level, then we'll now start subtracting.
और डिक्रीमेंट का भी कर सकते हैं, डिक्रीमेंट विद सेम एज 0.
Yes, वो कुछ भी डिपेंड करता है ना, इट डिपेंड्स अपॉन आप स्टेप. हो सकता है किसी को इंक्रीजिंग स्लोप चाहिए बहुत ज्यादा, लाइक फास्ट, एक राइज टाइम फास्ट चाहिए किसी वेव का, लेकिन फॉल टाइम आपको स्लो चाहिए, तो यू कैन डू इट दैट वे एज वेल. 3 again. Now we'll compare it with 0, 0. Okay.
सब ಅಲ್ಲಿ ಯಾರು ಬಂದಿ सब
I'm just trying. Just a minute. It's slow. Just give me a minute. Loop 1. I've written over here. 1 second. The space. Sub A comma. 1 second. How do we write it? Just give me a minute. #3. Sub SUBB, I guess it is. So now we are getting a square wave.
Sir, please share the code in the chat window, please.
Okay, all right. Just give me a minute. I'm just sharing it. Just give me a second. Yeah, so you guys can basically try it. Meanwhile, I'll just explain it again. I was busy writing it, so wasn't able to explain. So initially, I enabled the DAC. So in order to enable it, you need to give active low to the right pin. So P 0.0.7. So pin number 7 of port 0, I've cleared it. So this enabled the DAC. Then I started a loop. I started moving A into P1. I could have initialized it to 0 as well if I wanted to start from 0. Okay. Now I started a loop. I started moving A to P1. Yeah. So as P1 is directly connected to the DAC, suppose initially I moved 0, 0, so 0, 0, 0, 0 would have got moved to the DAC. It would have converted it to an analog value. Then I started adding 0, 3H to A. So if you want to have a steep the slope, then you can add 0.5, 0.7, 0.8, whatever you want to have, you can calculate, and accordingly you can move it. So I've used 0.3H. So this will basically keep on adding 0.3 to A till the time A reaches FFH. So this CJNE means compare A with the given value, and if it is not equal to that, just move to this loop start. So we'll keep adding 0.3 to A till the time it reaches FFH. So once it reaches FFH, it will move to the next loop. Here, as we need to decrement the slope, we'll subtract the values from A. So again, we are subtracting 0.3H. We'll again check whether A is becoming equal to 0, 0 or not. Let us change this value. Let us make this 0.6 and check if the slope changes or not. Where is the scope? You can see the scope has just a minute. Let me just update the frequency. You need to click on the scope. Or just a minute. Pause. In order to make it visible, I'll just. So you can see the slope which is going up, and the down, there will be a difference in that. 0.4 is not making it visible much. हाँ जी, just या मैं इसको 6 ही कर देता हूँ, एक सेकंड. Assemble and yeah. So this is the upward going slope, and the downward is, yeah. So the fall time is very, very quick if I compare to the rise time. X jump to the start 0 X. Okay. Yeah. So this way you can generate a sine wave you just need to make some calculations on how it will work, right? So in this way, you can generate different type of waves. I guess I'm having some question. No. Okay. Right. Let me just close it. Okay. So I guess we are almost about to reach the end time. So this way you can generate, like you can check for how to interface ADC. So that will convert it into a digital data, right? So it is having, if you'll see this, the ADC is having an input voltage, analog input voltage, right? So whatever input voltage you give to this, accordingly, it will give a digital data to your port 2. So same way, though it is a very basic sort of an interface, if I compare to now the what is available nowadays, right? We have some of the tools. Yeah. So, but to give a basic understanding to a student, you can obviously use it for them to have an idea of not only the coding part but the interfacing part, which is important for an electronics engineer. So this tool can be used, right? And it is having most of the basic, at least the peripherals which we have in a lab, right? So I guess rest of the things you can practice on your own.
Sir, how do you view this schematic, sir? In this?
Yeah. So you just need to click on LD, the logic diagram.
Okay, sir.
In order to view the schematic, just click on LD. If you want to change the connections, so you can go to dynamic interface. You can change the, suppose I don't want LED 5 to be connected to pin number 5. I can change it. So you can change the connection as well.
The one advantage, yes, LD is there. We can do.
Yeah.
We are using keys out.
Okay, sir. Thank you.
Okay. Yeah. Right. Yeah.
That's the disadvantage.
So I'll just call ma'am. So this is the program you guys can try. Sir, Garima ma'am.
हाँ जी मैं आ रही
So I guess it was a good learning session for you all. There were a lot of things to cover, so I just made the things a little bit quick. But at least for those who had a brief idea about the coding thing, so they would have got a good idea of how this tool is basically working. I hope it is a very handy tool for the students to learn, right? So I guess there are no questions. So I'll just say share one an assignment. So the questions will be related to what I've basically taught.
This can be downloaded along with Windows.
Yeah. It can be downloaded. Yeah. So we can wrap up the session now.
So thank you, Mr. Jatin. And if there are any query from any of the participants, online mode. Okay, I think there is no queries. So for online participants, we will have our validation at 2:30 p.m. Thank you. So we'll meet again at 2:30 p.m.
अब